Welcome to our introduction to trig functions. Here are the three main objectives of this video. Let's start with our first one and talk about a trig function, right? A function is a rule that assigns one output and only one output to every one input, right? You give it a number, it gives you an answer. We're going to use the properties of the unit circle to define trig functions. So what are these trig functions? Well, as we've talked about in other videos, every point on the unit circle can be designated, with an x and a y. What is its distance in the horizontal? What is its distance in the vertical from the origin? We can now start to define those points by trig functions as well. So if we use the x and y coordinates of a point, we can define several functions. The sine function, for instance, we can use to define all of the y coordinates for a point. And then the cosine function will be the x distances, and then the rest of them will kind of build off of that. So this is what we're going to do. We define sine of t. Remember, t was the distance that we traveled around the circumference of a circle. So we travel some distance t and we stop. We're going to define sine to be the y value, right? How high are we above the origin or below the origin? So what's the vertical distance? So wherever we stop, what's our vertical distance from the origin? And that's going to be sine of that distance t, right? So if we went around pi over 2, so if t, our distance was pi over 2, that puts us straight above the origin, and our distance is 1, and so sine of that is going to be 1, and therefore sine of pi over 2 equals 1. And then cosine is going to be defined as the left and right, the horizontal distance. And again, if we did pi over 2, our left and right from the origin is 0, right? We're directly above the origin. So cosine of pi over 2 is 1/2. So you can see that sine of t is going to be the y, cosine of t is going to be the x, i.e. the left and right. And t is always going to be, in our case, we're always going to be dealing with radians, but we can do it in either way, either degrees or radians. We just make sure our calculators are in the right mode. Okay, and then the rest of the trig functions are all built on top of sine and cosine. Tangent is simply going to be the function sine over cosine, so it's going to be y over x. And then cosecant is 1 over sine, so it's 1 over y. Secant is 1 over cosine, so it's 1 over x. And then cotangent is 1 over tangent, and 1 over y over x, right? If you divide something by a fraction, you multiply by its reciprocal, it just becomes 1 times the reciprocal. So instead of y over x, you get x over y. All right, those are all of our basic trig functions. And remembering which is which is kind of tricky, but here's one thing that always helped me. You'll notice that these things are all pairs, right? We've got sine and 1 over sine. We've got cosine and 1 over cosine. We've got tangent and 1 over tangent. Every pair has a co to it, right? So we have sine and then cosecant. We have cosine, so then we just have secant. We have tangent and then cotangent, right? So there's a co in each pair. That's how I could remember, which one went with cosecant, which one went with secant. Those are the tough ones for me as a student, is trying to remember secant went with which one and cosecant went with which one. And I just remembered, okay, well, there's always one co in each pair. And since cosine already has a co in its name, then I know it gets the secant. And then since sine doesn't, it gets the cosecant. All right, so hopefully that helps you guys memorize them as well. All right, let's see if we can find the 6 trigonometric functions for the given real number. We're going to start with pi over 3. And if we remember from previous lessons, pi over 3 puts us in quadrant 1. We know pi over 3 gives us a distance here of 1/2, a vertical distance of square root of 3 over 2. That's our point right here. So we already know, remember, cosine is the left and right. So doesn't that mean cosine has to be 1/2 and sine has to be square root of 3 over 2 because that's the vertical? Tangent's going to be sine over cosine. And then the rest, so on and so on and so on. So let's go through it. Here's sine and cosine, like we said, square root of 3 over 2, 1/2. Tangent, square root of 3 over 2 over 1/2. The halves cancel, you get square root of 3 over 1, which is just square root of 3. Cosecant, remember, is the reciprocal of this, so you flip it, and you get 2 over root 3, but then you rationalize the denominator. This one, you flip it, you get 2 over 1, which is just 2. You flip this one, and you get 1 over square root of 3, which, of course, you rationalize again, which gives you square root of 3 over 3. And there are our 6 values. Now, we know some basic values just because we know what happens around the unit circle. If we go up to pi over 2, we know sine is 1, we know cosine is 0. And if sine is 1, we know that cosecant is 1 over 1, which is 1. And we know that secant, which is 1 over cosine, would be 1 over 0, which is undefined. We know tangent is sine over cosine, which is also 1 over 0, which is undefined. And then we know cotangent, right, is the reciprocal. It's basically cosine over sine. So you get 0 over 1, which is 0. So we have 4, but the other 2 are undefined because they have zeros in the denominator. And that's going to happen, all over the place where you're going to be dividing by 0, and you can't do that, so they become undefined. So if we go back to those 4 kind of special angles that we had of pi over 6, pi over 4, pi over 3, and pi over 2, right? We didn't really talk about pi over 2, but it still is a special angle. All of those, and if we add in 0 as a special angle, we kind of get 5 special angles, but really the middle 3 are the only odd ones, because 0 and pi over 2 are easy because they're at the point, these kind of terminal points that are really simple. But we have now all of these numbers, these values from these ordered pairs as just values to a function. We now know that if we take sine of each of these things, we're going to get a certain thing, cosine, we're going to get a number, and so on and so forth. And we can put together this table very easily by looking at these, right? We know out here, cosine is 1, sine is 0, and then we build all the rest off of that. When we're here, we know that cosine is square root of 3 over 2, sine is 1/2, and then we build off of that, and so on and so forth. And that's how we can fill out that table very easily and have all of our kind of special values memorized for our trig functions. So as we saw from the first example, some of those functions couldn't be defined because we were divided by 0. And if we look at the previous slide, we can see that that happens quite a bit, right? There's 1, 2, 3, 4 of them that are undefined because we're divided by 0. So now that we know it's possible to have these situations where we're trying to divide by 0 and we know we can't do that, that means we have to restrict domains, right? We only have 2 things that ever restrict domains. We're allowed to do whatever we want, put anything we want into a function, unless it violates one of 2 things, dividing by 0 or taking even roots of negative numbers. And since none of these trig functions involve taking even roots, we don't have to worry about that. But since some of them are defined as fractions, right, we have to worry about the bottom of those fractions equaling 0. And so now, because of that, we look to see what happens to our domains. Well, sine and cosine, remember, are just defined as x and y. And so there's no fractions, so we don't have to worry about those, and they can be all real numbers. And then the rest, we have to worry about anytime we're doing, 1 over something and 1 over a 0, right? So all the rest have fractions and have problems. Tangent is sine over cosine, and then remember secant is 1 over cosine. So both of these have cosine in the bottom. So they're basically okay unless cosine equals 0. And where does cosine equal 0? Well, it equals 0 up at pi over 2, and then every 2 pi multiple of it, right? Pi over 2, in fact, every 1 pi multiple, right? Because pi over 2, and then down here at 1.5 pi, and then 2.5, and so on and so forth. So pi over 2 plus n pi, where n is any integer. We're going to have to take those out of the domains for tangent and secant. Cotangent and cosecant are the opposites. They have sine in the bottom, so they have a problem whenever sine equals 0, and sine equals 0 at when we start, right, at 0 and at pi and at 2 pi, right? So basically every n pi, every integer value of pi, where n is 0, 1, 2, right? So we can go around and around and around. So basically all multiples of pi. Okay, with that in mind, we can now find some values of some of these trig functions. And to compute values of trig functions for any real number, we first have to figure out their signs. We have to figure out, is it going to be positive, is it going to be negative? So for example, if the terminal point lies in quadrant 3, we know which functions are positive and which functions are negative. And then we can figure out the values of those functions, because it's going to be easiest to kind of deal with reference values and then just change the sign depending on which quadrant we're in. Now, do you need to memorize this stuff? No. If you just go back to kind of drawing your unit circle, you can always remind yourself and remember which function is which. So as we go around, well, first, we definitely have to have this memorized, which quadrant is which, right? That we start in the first quadrant and then we go counterclockwise. All right, but if we're in this quadrant here from quadrant 1, both x and y are positive. So sine and cosine are positive, and then since everything is built on those, everything is positive, and that's why they're all positive. We come over here to quadrant 2, and now our x value is negative. So that means cosine is negative, and sine is positive. So now anything that has a cosine in it is negative. So secant, which is 1 over cosine, and then the tangent and cotangents, which are sine and cosine, combinations. One is sine over cosine, and then cotangent is cosine over sine. Those are all going to be negative. Then we come down into the third quadrant, where everything is negative as far as sine and cosine, right? Sine is negative because it's down. Cosine is negative because it's left. So we get sine and cosine. And then 1 over sine and 1 over cosine are both negative. So that gives us the cosecant and the secant. But tangent and cotangent are, sine over cosine, the negative over negative, they cancel. And then cotangent is the flip of it, right? Still negative over negative, and those cancel. So that's why those are still positive. And then in the fourth quadrant, cosine, the x value is back to being positive, but sine is negative. So if sine is negative, we know that's negative, and then its pair, cosecant, is negative. And because sine is negative, but cosine is positive, we get the two ratio ones of tangent and cotangent are negative. So do you have to have it memorized? No, but you'll figure it out very quickly if you just draw a picture. Okay. How do we evaluate trigonometric functions for any real number? Well, it's easy. All you have to do is find the reference number. Figure out where you would be in quadrant 1. Figure out what the trig function value is for that distance in quadrant 1, and then figure out what the sign is depending on what quadrant you're actually in. Now I know these steps kind of do those last two in reverse, and you can do 2 and 3 in any order you want, but basically those are the three things you have to do. You find the reference number or the reference angle, whatever you want to call it. You figure out what quadrant you're actually in to help you determine, whether you're positive or negative. And then you determine what your actual value is based on the reference number. Put all those three things together, and you've got your answer. Let's look at some examples. All right, let's start with the first one. Cosine of 2/3 pi. Well, if we go 2/3 pi, we're over here in quadrant 2. Our reference angle is pi over 3. We know from pi over 3 what the value of cosine is. We know it's 1/2, but because we're over here in this quadrant, we know it's negative, so we get negative 1/2. What about for negative pi over 3? We're down here at negative pi over 3. We know the reference is pi over 3. we're doing tangent of this one, right? Well, if we're down here, cosine is positive, sine is negative, right? Because we're at a positive x but a negative y. So we know that tangent is going to be negative. If we think about what tangent of pi over 3 is, it's just square root of 3, but the negative makes it negative square root of 3. See how easy this is, guys? Everything goes back to those reference angles, those reference values. So if you can just get those kind of memorized, you're good to go. And even if you don't have them memorized, if you just have the points, the pi over 6, the pi over 4, and the pi over 3 memorized, then you know what everything is because you know cosine is the x value, sine is the y value, and everything else builds off of those. Okay, 19 pi over 4, right? 19 fourths pi. You can take away 4 pi's, and you're left with just the remaining 3/4 pi, which means we went around twice, and then we stopped here at 3/4, which gives us a reference of 1/4. And at 1/4, we know what the value of sine is, and sine is positive in both, so nothing changes. So we're basically figuring out what the sine of 1/4 is. We know that's square root of 2 over 2, so we know the answer is square root of 2 over 2. Okay, now all of your scientific calculators can find values for all of these things as long as you're in the right mode. So make sure you put yourself in radian mode if you're dealing with radians, and put yourself in degree mode if you're dealing with degrees. If you have one of the kind of less fancy calculators, the answers it gives you is always going to be a decimal, and there's nothing you can do with it. If you have a super fancy calculator, it'll take that decimal and it'll convert it to fractions, but most of them still can't even convert them to, square root of 2 over 2. So just know that you can do all of these in the calculator, but if you're required to list the precise answer, i.e. square root of 2 over 2 or square root of 3 over 2, you cannot get that out of your calculator because it's just going to give you the decimal equivalent, and then you're going to have no way of being able to convert that back to square root of 3 over 2 or square root of 2 over 2, depending on the ones you're doing, or any of the other reciprocals. So just keep that in mind, that you really need to do these things by hand rather than with technology if you want precise answers. Now, since we've defined everything in terms of sine and cosine, we know that we're going to have all of the same kind of values popping up again. Instead of a square root of 3 over 2, we get a 2 over square root of 3. And then we have to rationalize the denominator. So we're just reminding ourselves that all of these things, because the functions are defined as kind of reciprocals, 1 over, then the values are going to be reciprocals. Now, what if we wanted to find trig values of odd things instead of stopping at pi over 4 or pi over 3 or 7 pi over 4? They just give us a decimal and say what's sine of 2.2 or just what's cotangent of 28. We'll just plug them into the calculator and go. Just be careful. These things are assumed to be radians because they don't have that little degree circle next to them. So a lot of times students will look at this and goes, well, how do I know if these are degrees or radians? Well, if it was a degree, it would have that next to it, and then you would know it was a degree, and you would put it in degree mode. But without that little red circle, it's assumed it's a radian, and you need to be in radians mode. So all of these are simple. Plug them into calculators, get your answer. Now, if we want to talk quickly about what it means to be odd and even functions, we have to think about what it means to be positive t and negative t. If we go the same distance clockwise that we go counterclockwise, we know that the verticals are going to be exactly the same, only this is going to be positive y, this is going to be negative y, and we know the horizontal is going to be, in this case, exactly the same as x. And in fact, if we go around over to here and around over to here, the x is also going to be the same. The only time things really change is if we go all the way around to here versus all the way around to there. We can see that the x's are still the same and the y's are different, right? So once we start looking at these similarities, right, wherever I stop, the x's are the same, but the y's are the opposite. What does that mean? What does that tell me? Well, it tells me that the x functions, the functions that are built on x, are what we call even functions, because if we go negative or positive distances for t, we end up getting the same thing. And then we saw that all of the y ones, right, all the ones that are built on the y, were always opposites. We were always getting positive y versus negative y. We call those odd functions because we get the same number but with opposite sign. So that tells us that if we go sine of negative t, we get the exact same thing as just negative sine of t. But cosine, because it's built on the x, they're the same, right? Cosine of negative t and cosine of t are exactly the same. Because tangent is a combination of sine and cosine, it's both even and odd, right? The y's change, but the x's stay the same. So basically we get that negative and we get opposites, right? Negative t versus negative positive. Cosecant, because it's just 1 over sine, it's going to act the exact same way as sine. Secant, because it's 1 over cosine, it's going to act the same way as cosine. And then cotangent, because it's 1 over tangent, it's going to act the same way as tangent. So you can see that we have 1, 2, 3, 4, right? 4 of them are odds, and the only evens are the cosine and the secant. So the only way you can be even is if you're built on x. Everything else is odd. So now that tells us that sine of negative pi over 6 is going to be negative of sine of pi over 6. If we know what sine of pi over 6 is, we know this is just going to be the opposite, right? So if the first one was 7, this one would be negative 7. Now we know it can't be that because our answers are never bigger than 1. But you get the idea. If we know what sine of pi over 6 is, and in this case it's 1/2, then sine of negative pi over 6 is just going to be negative 1/2. If we know what cosine of pi over 4 is, we know cosine of negative pi over 4 is the same because they're even. And at pi over 4, we're square root of 2 over 2. So this one, we're also square root of 2 over 2. If we go through the kind of the steps of it, well, here's sine of pi over 6, like I said, was 1/2. We now know it's negative because sine is odd. Cosine of pi over 4, right? Pi over 4 right here, cosine square root of 2 over 2. And because it's even, it's the same. So with some of these little kind of fundamental things, we can now broaden the number of angles that we know answers to. And it's all built off of those 3 special ones in quadrant 1. Okay, something else that's built off of that are these basic fundamental trig identities. And in fact, all of these, well, the top row you already know. I mean, you should already know, right? These are just restating how everything is defined, right? Everything's defined in terms of sines and cosines. That's simple. The new bit of information is this right here. And you already knew that because you already knew Pythagoras' theorem. Because remember, if we're on the unit circle and we have some point, then we think about drawing a line from the origin to that point, and then we drop a line straight down. It creates a right triangle. This is my x value. This is my y value. This is 1. I know that x squared plus y squared equals 1, right? X squared plus y squared equals 1, because that's also the equation of the circle. But didn't we define x to be cosine and y to be sine? So this is really cosine squared plus sine squared equals 1. And that's our first Pythagorean identity, and it's really just Pythagoras' theorem. Sine squared plus cosine squared equals 1. Okay, well, what about these next two? Where the heck did these come from, and how do I memorize those? Well, you don't have to memorize them because all they are is manipulations on this one. If you take this original identity, which should be pretty easy for you to memorize, and divide everything by cosine squared, you get this one. And if you take everything over here and divide by sine squared, you get the second one. Because so let's divide by cosine squared. Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is just secant squared, because remember, 1 over cosine is secant. That's where that one comes from. Okay, take this thing and divide by cosine. I'm sorry, divide by sine squared. Sine squared over sine squared is 1. Cosine squared over sine squared, remember cosine over sine is cotangent, so when you have two of them, right, it's just cotangent squared. And then 1 over sine squared, well, 1 over sine is cosecant, so you just get cosecant squared, right? So those are just built off of the Pythagorean theorem. So don't think of it as 3 things to memorize. Think of it as 1, and the 1 you already know because you already know a squared plus b squared equals c squared. And then everything is built off of that. All you're doing is dividing either by cosine squared or sine squared. Now, the fundamental identities are going to play a central role in trig because we're going to use them to solve a lot of trig stuff. So that's why we want to learn those three. And if we have those fundamental identities memorized and we realize that everything is based on a right triangle, it helps us find other values of other trig functions if we just know one of them. So if we're told that cosine equals 3/5, we can use these simple trig identities to then solve for sine. And then once we have sine and cosine, remember all the rest are built on top of them. So we plug in 3/5, we do the math, it tells us that sine has to be either positive or negative 4/5, but because they told us we're in quadrant 4, which remember 1, 2, 3, 4, we're down over here on the right, sine is negative, so that means we know sine has to be the negative 4/5, and then based on that, we can build all the rest. Here's negative 4/5, here's 3/5, and then build everything off of that. Now there's something that we're going to learn in another video, right triangle trigonometry, where we don't even have to use this Pythagorean identity to figure these things out. Because if we go back to drawing our picture, right, we're down here in quadrant 4. So there's the origin, there's the x-axis, there's my vertical, right? Here's the triangle that it created. It tells me that cosine is 3/5. Well, remember, cosine is the x direction. So this is 3/5, and then this is y, and this is 1, and then we can solve it that way with Pythagoras' theorem without even thinking about Pythagoras' identity. And when we get to right triangle trigonometry and we learn SOHCAHTOA, it'll become even easier. So if you want to help yourself with these types of questions, go refresh your memory on what SOHCAHTOA is, and you can solve them even faster. All right, hope that helps.